In part 1 of this video, I described how I was looking for an AVR or Arduino controller to suit a couple of projects that I had in mind. And the requirements were that it have a higher than average number of IOs, like at least 30, that it be easily incorporated into another project, embedded, like for instance the way this Nano is part of this project, or that Nano is part of that project, this Pro Mini is part of that, or even this MightyCore variant, which is part of that project. Other requirements were that when it is used like that it doesn't impose too stringent requirements on the printed circuit board. For instance, a Nano only needs two single rows of pins, so very easy to make a printed circuit board like that, because I wanted to be able to do homemade PCBs for one-offs or quick turnaround development. Things like this are not really suited. I don't like having double rows. It's alright in the manufactured board like this, but in a homemade board it's a bit harder to deal with double rows like that. And another requirement of course is that it be cheap. And I looked at the standard, more common Arduino types that are available, the ones I knew about, which were the Uno, Pro Mini, Nano, 2560, Mega 2560, or that variant, and pretty much decided that none of them really met my requirements, and that a pretty good solution would be to use one of these old style 40-pin dip packages. This is an ATmega32, but there are 6 or 7 different chips that have the same package and the same pin outs and can be used interchangeably, and some of them have up to 128k of flash and 16k of RAM, and still not too expensive. With this you don't even need to have a module like a Nano. Even if you did put it on it in a module, it wouldn't save you much space, because you've still got to get all those IO pins out. Now that's what you're doing it for, is to have all those pins. So, and even if you use the SMD version, like something small like that, the SMD version of one of these, you'd still need a module of nearly that size or bigger to get all those IO pins out. Because one of the requirements that I'm looking for is easy PCB manufacture, so 0.1 inch spacing, and that also means that it can go into a breadboard easily. And so you don't even really need a module, although it would save a little bit of trouble. You wouldn't have to deal with having to put the crystal and programming header in your project or in the breadboard. It could be built into the module like they are with this Nano. You can just stick that straight on the breadboard, put on your crystal and capacitors and programming header, and away you go. And so what I've decided is I can do something similar to what I've done with these ATmegas in that project and in that one. Just build them straight into the board, add the crystals and capacitors and the programming header, and away you go. Bob's your mum's brother. Now, because I was thinking about ATmega32s, I saw these gizmos on AliExpress and bought them. I only meant to get one, but I got 2, and that's alright. They're not too expensive, and I did a bit of a review of them in part 1 of this video, how they've got the zip socket and all the pins are brought out, and the pin out of this chip is quite convenient. All 8 bits are brought out in 4 places, and of course you wouldn't use this module in a project, but it's handy for experimenting and developing, and you might not even need a breadboard because you've got all the pins brought out for you already. So it's just pretty convenient little thing for playing around with. But probably the really most valuable part of that is this USBASP programmer, because with that and the right cable you can program any of these things. Now, for instance, that cable programs this, but if you took that off you could and used one of these little adapters, or made up a whole new cable. This goes to the 6-pin style connector, ISP connector, so you can program that one, or that one, or that one, or you can just do it mucking around with wires to get to the Uno. You can't plug this straight on, sorry, the Pro Mini, you can't plug this straight onto anywhere there, but you could have some flying leads going to the right pins. So this can program anything, and you can also use just an Arduino like that. That Nano has got the Arduino ISP sketch in it, one of the examples that comes with the Arduino IDE, and using that you can program a chip. So it's equivalent to that. You know, you could connect to that any sort of cable you like to also program any of these things, though it does use the serial communications rather than high-speed USB. So this is a lot faster. That's a desirable thing to have, but not essential. You can do this. That's a desirable thing to have, but not essential. You can use a breadboard. We've made all the decisions about using this chip. Now I want to talk about how to program it, and specifically how to make it behave like an Arduino, because straight out of the box Arduino doesn't know this chip or this board. And yeah, I went through quite a bit of rigmarole to eventually get it to work as an Arduino, and I only did the most simple test, yet to be seen if there's other issues, like I only got to do the blink sketcher. What about using the peripherals inside of it? I haven't even got around to trying to use its UART or its ADC or its PWM or timers or all the other onboard peripherals, on-chip peripherals. I don't think I'll be able to experiment with all that in this video, but at least I'll be able to point you to something that claims to do the job. So after that rather long introduction explaining how I got to the decision to use these chips, the next thing to do is get the software working. Now, if you're impatient, the short answer is MightyCore, which can be found on GitHub, this thing. Download that and follow the instructions. There's manual and automatic. Do the automatic, because the manual didn't work for me. The manual installation is common to a number of these Arduino updates for these chips, and I couldn't get any of them to work. They all caused some sort of a problem. And just as I was digging through all this stuff, working out where I was going to go with all this, I realised that it was going to get messy fooling around in there. So I thought, first what I want to do is just verify this with the simplest possible means, which is to go via assembler, an AVR dude, leaving Arduino out of it, because I knew the assembler could cope with the chip, and I just have to tell it how to deal with AVR dude, which it also knew how to do, but it didn't know how to use this particular interface, the USB, rather than the serial that would be used for talking to a bootloader. So fire up the assembler, and here's just a basic blink sketch, few definitions. Main loop, set a LED, delay for 1 second, clear a LED, delay and loop around again. And there's the subroutine to delay for 1 second. So if I compile it, yep, it works. Notice only 38 bytes compared to what a sketch would generate. Now this is a virgin ATmega32, it's got nothing in it, and I hope that's readable. I've got the camera pretty close to the screen, but I need to have a little bit further away so that we can see this thing. Actually I should use this one because it's got the extra LED on it, so I'll swap this one in. Now you can see there it's got USB ISP. All I have to do to get this thing going, in its configuration file, I just had to add this entry here, a new type of downloader. Instead of Arduino or AVR ISP, which is, you'd use Arduino as for just talking into the serial comm on an Arduino of a bootloader. AVR ISP is for using this arrangement where the sketch in that is acting as a programmer, and so you're going via that to program this. All I have to do is add this extra one and specify USB ASP. That's all I have to do. So now I go into assembly. If I just select that and read signature, Ding. Unexpected results. Cannot open USB device. Function not implemented. First time I run on this computer. What's going on here? Dickhead. Before we do that, we have to install the USB driver, or can't see it, can we? We have to install the USB driver for that. The easiest way to install that is look for something called Zadig or Zadig. There we go. And I've already downloaded it, but you just download it and follow the instructions, which is basically press that button. So there's the Zadig that I've downloaded, so I'll run that. Install driver. Okay, and now when I go to the assembler, target, read signature and fuses, it works. So that's all I have to do. You have to install Zadig before you use this thing. And then it read the fuses out of that, blah blah blah, and decided yes, it is an ATmega32. This is a pretty crappy little PC. It's got a very small screen, so not much room for anything. Right, there's problems with the size of this display, and this program has still got lots of bugs in it, but now I've found my buttons so I can read from flash, and there it goes reading. So this is a whole lot simpler than trying to do it in command lines and things. I hate command line programs. You'd have to open a command box and type in all this gibberish for AVR-Dude. I didn't want to do that, and that worked, and there was nothing. AVR-Dude refused to fix this bug. They call it a feature, but when you tell it to read flash, it reads flash up until the last block of FFs, hex FFs, and in a blank chip it's all hex FFs, so you get no bytes downloaded. When you say read flash, it should read the flash, whatever's in it. They call it a feature because it aids with programming later, but the read flash command is read flash, not read flash for later programming. Anyway, so we'll take that as an empty chip. I go back to here and just compile it. Hopefully we'll install it. Ding, done. PB5 I think it was. Oh, that's the, what was it? Yeah, PB5. That's the standard Arduino. On most Arduinos, PB5 is where the onboard LED is. And you can see it's not working. That isn't on. How to do anything with that off? It's on now, it's not flashing. Let's download that program again now that I've had the power on. Oh look, it went off. This had me fooled the first time I saw it too. It is in fact working. It's just flashing really slow because this delay value here, 81, see it just turned on again. This delay value 81 here is a delay for 1 second at a 16 megahertz clock frequency. But this has defaulted, because it's a virgin chip, its fuses have defaulted to using internal 1 megahertz oscillator, so it's 16 times slower than it should be. So every flash on and off is 16 seconds. So we've got to change the fuses. How do we do that? Well, there's the fuses there. And what, I worked this out before. I hate dealing with fuses, it's really complex. I think it was, I'll have to run up and look at it. I think it was EF. Let's just try that and write the fuses. Yeah, that's more like it. But it's still not 1 second, isn't it? And that's because it's got an 8 megahertz crystal, not a 16 megahertz. So if it's now using the crystal, but it's not a 16 meg crystal, so we change this to half that value, 40. And there it is, working as it should. So this hardware works. And if we go to look at the read the flash. Down there, you see it's reading, and we should get something this time. 38 bytes. We've got to read all of it to find out that it's mostly FFs, and then ignore all the ones that come after these 38. And there it is. There's what's in flash. 38 bytes. That's the sketch, the result of assembling this program. Let's make it go a bit faster just for fun. 4 times faster. Now there's more to these fuses than we've looked at thus far. If we were to change that to, I think in port C, over here, I think the middle 4 of port C, so that's PC 2, 3, 4 and 5 I think, are the JTAG interface, and by default they're enabled, so they're not available for I/O. So if I was to change that program to use PC3 say, I don't think it would work, because you have to set another bit in the fuses that disables the JTAG, and then I haven't looked up how to do that and I won't bother with it now. Let's go on to, now that we know that works, let's look at what's involved in making it work in Arduino. If we go to Arduino, this is a version installation of Arduino. We don't need that. Let's get the blink sketch, some examples. Now if we try to run this, it won't work. If we look in tools, there is no option for one of these things. We can tell it to use USBASP, which is this thing, so we can do that, but it doesn't know about ATmega32s or this. So the methods they tell you for installing the support for ATmega32s is, if we go down into here, AVR, not tools, but Arduino, AVR, we see there's these 3 files: boards, platform, programmers. And boards, a WordPad I think will work for, yes. There's all these entries for different devices, and some of the instructions I saw for installing ATmega32s just involved adding entries into this file, and then you have to also, in variants, you have to add, if you look in these variants, you'll see they've all got the same file in them. Well, it's not the same file, it's different for each of them, stupidly. But you have to create a new folder for ATmega32 and install, copy in a version of pins Arduino H for ATmega32. And I found several instances of that file to use, and along with the entries to put in the boards.txt file, and none of them worked. And even with that MightyCore, it has manual instructions which involve doing the same thing, adding entries to this file, creating a folder inside of variants, and adding a pins Arduino.h file into the new folder. A version of that specifically for ATmega32. Couldn't get any of it to work, but there is an automatic installation that comes with MightyCore and not any of the others, and that does work, so I'll show you that. If you download MightyCore from where I showed you before, you get mightycoremaster.zip. I've already done that and extracted it, and there's the readme file. Right. Yeah. How to install Boards Manager installation. You stick that, copy that URL, you go to File, Preferences, put that in there, okay, then Tools, Boards Manager, and give it a little while and it should download an entry for MightyCore. There it is. and just install it. Installation completed. Right. Now if we go to Tools, Processor, now we've got two levels of menus. That's the original one that was at the first level before, and now we've got MightyCore. And we'll go to ATmega32, external, but this is an 8 MHz crystal. So I've got having trouble with this mouse. External 8 MHz. Bootloader, do I want that? Let's just for the moment just say no bootloader. And programmer, we want USBASP. You don't need to use slow, I'm pretty sure that the normal one works. And now this should download, I think. Let's try it. Compiling sketch. And is it working? Well, it may be. We might not have the LED in the right place. The sketch specifies LED built in, and I haven't got programmer's notepad on here, I don't think, which is what I would normally have for opening these things. LED built in 13. Well, that's what is pin 13 on this thing. Somewhere there is, I saw a diagram of what the pinouts are for MightyCore. Yes, this is what I was looking for. You get three different layouts. If we look at, where was that in, I think it was in Arduino. If we look at Tools, yeah, pinout, you got standard, Arduino and Sanguino. We're using standard, so that's this. Yeah, I think maybe I just said, maybe the zip socket's dicky, or this was loose. I think it is using PB5 as per a normal Arduino, even though it says LED there, PB0 on standard configuration. You have to do a bit of digging. But yeah, that seems to have worked. If we go back to assembler and read from the memory now. Hang on, that's my original sketch, that's not the Blink sketch from Arduino. It didn't download from Arduino. What's going on? We selected ATmega32, external 8 MHz, standard pinout, no bootloader, using USBASP, and then say download. Now it says 933 bytes of flash verified. You'll notice there's a message in here, warning, cannot set SCK period. Please check for USB firmware updates. There is a video on YouTube I saw for updating the firmware inside this chip on the USBASP, but from what I gather, that message is completely unimportant. You can ignore it. But according to that, it's downloaded flash, but we haven't got a blinking LED. Why not? Is it not PB5? Is it PB0? Yes, it's PB0. So this document, which I think downloaded with MightyCore, it has those three different pinouts, the standard, Arduino and Sanguino, and oh, I should have been looking at that, dickhead. Right, in Arduino we've selected standard pinout rather than Arduino or Sanguino, so looking at this one, pin 13 is PD5, that's not what we want. It said it's working off PB0 obviously, we're on PB0, which is here, oh yeah, LED. So in the standard configuration that's where the LED is. If we were to say go to Arduino configuration, the LED would move to PB7, so let's just try that. Go to Tools, select the Arduino pinout, compile and download, verified flash, and now that LED is not working. It should work on PB7 though, so we switch to here, and away we go. So yeah, things are making sense a little bit. And if we try and download the flash, this is such a terrible little screen on this PC, on this laptop. So there's the sketch, and as you can see it's a lot bigger than 38 bytes that you get out of assembler. But it finishes at address 3C0, so there's no bootloader at the top of memory, there's just a sketch in the low part of memory. So the next thing to do is burn a bootloader. So going back to Arduino and tools, and we say burn bootloader. Did that work? What do you have to do to make it burn the bootloader? I'm sure you just have to do that. Burn bootloader. Maybe you have to tell it, yes, use a bootloader. I would have thought that was for downloading sketches after you've burned the bootloader, but let's see what happens. Burn bootloader. No. Still not doing that. Why? Why can't we burn the bootloader? I did it on the other system. Okay, I think I've figured out what's going on there. It actually did burn the bootloader. It just happens very quick because the bootloader is quite small. It's a hell of a lot smaller than that blink sketch. So just to recap, I'll go back to this assembler thing, blinking every second or thereabouts. Now, read the memory. It's got to read all 32K, so it takes a little while. But when it's done, we'll see that there's only that short program at the start of memory. Right, just that's it. If there was more, there'd be a bunch of FFs. If it was a bootloader, there'd be a whole lot of FFs and then the bootloader at the end of memory. But there's just that, because every time you program this, at least through AVR-DUDE, it erases the entire chip, bootloader and all. Yeah, the memory is just got those 38 bytes in it. Now I go to Arduino and do the burn bootloader, but I'll have that first. I'll set that with have that set to no bootloader. Do it. It all seems to happen very quick. That empty.hex that you can see there, I think maybe that it just burns that as part of the overall burning process and replaces it later. So now, if we go back to the assembler and read from flash again, all 32K of it, yes, empty, nothing, there's nothing in there, it's clear. We burnt the bootloader, but we said no bootloader, so it burnt nothing. Now we'll say yes and burn the bootloader. Yeah, that's all very quick, it doesn't seem to take long at all. Read from flash. And see, now I've got a whole lot of FFs. That sketch has gone from the start of memory because we erased the chip as part of the programming process. That happens every time, except it doesn't, sorry, when you burn the bootloader, it erases the whole chip. And we go right down here, and at the very end, there's the bootloader. You can see it's not very big, 512 bytes. It's smaller than the Arduino sketch for a blink. Okay, so the bootloader, and doesn't even use all of memory. There's some unused bytes there, those FFs. So, I'm sorry that was so confusing. I got confused. To summarise, you first go to Zadig, download their driver installer, run that installs the libUSB driver for talking to these things. Then you download MightyCore, unzip it, and in the README there's a URL that you paste into here, and then you go to Tools, Boards Manager, give it a minute to look for it and find that MightyCore, and I've already installed it, so it gives me the option of removing it, but yeah, you'd have install there and you install it and you're done. Now, and then you go to Tools, you set up which chip you're using, what its clock frequency is, which pinout you want to use. Yeah, sorry, I should have set that back to standard, that's because I've moved the LED back to PB0. Say bootloader yes, and then burn it. And now it's in there. But we're not using it yet, we're still programming via this USB ASP. To actually use the bootloader, we've got to connect one of these USB to serial chips. So yeah, I'll do it on this one because it's got the standoffs, because I'm going to put a capacitor on the bottom, so those standoffs will give me room to put the capacitor. Yeah, power and ground to here, transmit and receive to transmit and receive, but crossed over of course, because transmit out of this is receive into that and vice versa. And then the DTR signal here, 100 nanofarad capacitor from that to the reset pin. And then I should be able to take that out, plug that in there, and just use normal sketch upload. So I'll wire this in, and or rather I'll wire a header for that, and then I can plug this in when I want. Back when I've done that. Alright, so here's my handiwork. I was going to try and make it go horizontally so I could plug this in like that, but there's not enough clearance with those spaces, so I put it there, which means I have to decide, does it go this way or that way, and I've decided that way because it's a little bit more stable, and when you're doing this then you won't have anything plugged in there. Free to use when you want to burn the bootloader or whatever, and then when you want to use the bootloader via serial comms, you plug that in there. And used a giant capacitor, it's 100 volts I think, it doesn't need to be that big, but I have one lying around. I think my connections are okay, and if I'll just test it, and if it does work then I'll hot glue all over it to keep everything in place and insulate it. So let's see if it works. Yeah, so I plugged it in, there's the LED's on, but if I turn the power switch on and off we get different brightnesses on the LED, so maybe I should have connected the power from this to going into the switch. Not sure. Anyway, I'll just run it so it's bright. Let's fire up Arduino. So we've got to change the programmer from USBASP to AVR ISP, and then COM6 again. Select that and run the blink sketch. Compile and download. And problem uploading to board. Program is not responding. So, not working. Bugger. Maybe my reset thingy is no good. Yeah, but it worked. And I've got a blink. Well, that's looking good. Why was it a bit dicky up front? I did press the reset button during all that, so maybe that had something to do with it, because and my capacitor thing is not working, and pressing reset did what it should have done. I just realised what I think might be the problem. This little 0.1 microfarad capacitor is trying to drive reset, but it has to fight against the 10 microfarad capacitor that's built into the board going to ground, which was a little SMD part down there. So I've desoldered him, and let's see if Arduino can now work the reset line. Still no good. Very annoying. Oh well, I'll keep digging around. See if I can find out why that is. Bloody dickhead. I thought there was only one 10 microfarad capacitor on this board, but there's two. I took off this one, which is on the power supply. I should have removed this one, which I now have, which is on the reset. So I don't think they're polarised, they just look like ordinary ceramics, but 10 microfarad ceramic, I didn't think they came that big. We'll find out when I plug it in. If there's an explosion there, then it was polarised. Okay, now I'll try running the sketch again, burning the sketch again. Yay, it worked. So now we have effectively an Arduino showing ones. Okay, now if I ground PB2, that should turn to a 0. And we get zeros. Take it off and we get ones. That looks like that's working. It's probably gone on long enough. Let's hope that they've done everything right in that pins Arduino.h. Let's hope that they've implemented that properly. This is not the one that came with MightyCore, but all this stuff in here has got to be set up properly so that the Arduino IDE understands this ATmega32 chip, and let's hope that they've done it properly. Just by the way, this folder here, under your users folder for the particular user, then you've got AppDataLocal Arduino 15. That appears to be where all the libraries you download go, all your preferences, settings, and if you can get yourself in a knot, deleting this folder often clears things up. Like if I delete that folder now, the Arduino IDE will start up, but everything I've done since I installed it will be undone. So I'd have to reinstall that MightyCore stuff. But yeah, if things get all locked up, not working anymore, you can delete that and things will come good. Hopefully all that stuff is right and this thing is perfectly good Arduino using an ATmega32. Alright, I think we'll leave it there. So in summary, to get one of these things working as an Arduino, you first have to download and install Zadig or Zadig to get the lib USB drivers into Windows so that it can talk to this USBASP. Then you download MightyCore, unzip it, and in the documentation for it there's a URL that you then paste into file preferences in Arduino. Then you go to Tools, Boards, Board Manager, wait till the MightyCore appears, install that, and then the IDE is set up for talking to these guys. You change the program to USBASP, pick which board you've got, what clock frequency you want, which chip you've used, ATmega32 clock frequency, yeah, 8 megahertz for this one, and then set Bootloader to yes and burn Bootloader. Then you can start using these boards, but you have to connect a capacitor from DTR to reset, power and ground, and there's the blue and white wire is transmit and receive, and if you do them that way they cross over, which is what you have to do. I hope my ramblings have made some sense. I've shown all the idiocy along the way, or most of it, because some people like to see what problems you run into when doing things, and yeah, so I've included warts and all. I hope you enjoyed, and I hope it was useful. I feel like it might be a complete mess, but we'll see what I can knock it into when I edit it. Anyway, catch you later.